Good morning, welcoming you again to this foundation engineering lecture, and we are discussing on pile foundation, and this pile foundation various aspects already we have discussed, and we have discussed about the capacity of piles, particularly single pile, and we know that in actual practice single pile hardly used. In fact, pile always has to be used in a group. There are several reasons. So, I will take today the group pile, some details how we do and what are the difference when you use single pile and group pile. And then in fact, I have not taken any problem so far on pile foundation, particularly for determination of pile capacity etcetera. So, I will take the problem immediately after this, actually just I will discuss first the group effect. That means, when pile is used in a group, whatever analysis we have done for single pile, how it will be different from that, and or what modification is required to find out the final capacity or group capacity of the pile. So, let me start with the first slide. As I have mentioned already that piles in a group, the behavior of a group of piles is different from that of individual piles in a number of ways. That means, not only one reason or one point that it is different only this, there are several ways it is different, and in general you can see bearing capacity or of the group of piles is less than the sum of the capacity of the individual pile. Suppose if I get a pile particular pile capacity, suppose Q I, and then I can, if n number of piles are used in a group, then n Q I is logically supposed to be, but if I do this and if you find out actual capacity of the group, they are different. That is the thing mentioned here. And for pile foundation, this bearing capacity term may not be a very good one, or it is actual capacity, only capacity may be better, capacity of the group. Bearing capacity means only, since for pile capacity comes from friction and base, and bearing capacity means looks upon the brace only. So, though loosely I have used here bearing capacity is nothing but capacity of the group and capacity of the single pile. How they are different? Logically we may think that group capacity of the pile will be n multiplied by the individual capacity, but it is not so, they are different. That is what first point actually you have to make it note, that is the one most important difference. And then settlement of the pile group is larger. When the pile is used in a group, whatever amount of settlement will be there, and same magnitude of load if we use or not same magnitude corresponding, that means, if n number of piles, group piles, suppose 10 piles in a group and it is 100 kilonewton, then one pile will carrying approximately 10 kilonewton. Now, the 10 kilonewton pile load if you individually apply to a pile and 100 kilonewton load in the group, that settlement again is not same, it will be different, and efficiency of the pile group is less than of single pile. That is the thing, that means 100% thing will not get. Next thing is that the piles in a group, actually when they are in a group, particularly the friction pile or end bearing, both are there, then they are actually interact with each other, this pile and this pile. So, it will, when it will be transferring the friction like this, then it will have the influence zone something like that, and it will also will have influence zone like that. So, if they are very close, both the influence diagram will be overlapping, and in that case that is called interaction. That means, this pile is affecting this one and this pile is affecting this one, and that happens, then we will not get the full capacity. That is what they affect interact with each other, and this interaction, because of this the effects depend on the soil type, that what type of, whether it is sand or clay, and the head fixity condition, that means this side how it is, and the other fixity condition and the configuration, that how we are arranged, all those things actually the capacity, whether when you are using in a group, how it will be different from the n multiplied by individual capacity, that depends on number of factors such that is pile soil type is one of the most important factor actually in configuration, than how closely you are spacing or how widely spacing we are doing, that is also another aspect actually it affects. Next thing is as I have told that when you are using in group, you are getting lot of negative. That means when individual pile capacity, if I see that 20 and if I use 5 piles together in a group, then it is not 100. That means you are getting less, it is a negative. Again 20 kilonewton load, if I apply a pile and then whatever settlement you are getting, and 5 piles you together put a pile cap, whatever settlement you are getting, that you are getting group settlement is more. In that case, that is also another negative. That means our aim in the design actually the keep the settlement within some limit. So, if the settlement is more, that is also another negative. So, though we have several negatives, still we have to still there is no option other than using pile in a group. So, this is the thing I mentioned here, that in spite of these shortcomings, that whatever I have mentioned, a pile group is a much more common occurrence than a single pile. That means, single pile hardly used, it is always in a group most of the time. Single pile lack the overall stability. That means, if one pile is there and over that if you make a one pile cap and then footing, then looks unstable actually, it is always. So, lack of stability against overturning, a deficient that is easily overcome by a class. Suppose, if this is the one configuration, and another configuration is, suppose you will put pile like this, and then pile like this, and then you put a common one, and then you construct the column, then it will be much more stable than this. So, that is the thing. So, because of this, first of all, since when the load is very large, then you have to use a group, and again if suppose by single pile also whatever load you have you can manage, but still will not do, because stability is one of the issue comes there. So, these are the, in spite of so many shortcomings, that is we are actually using pile in a group because of several reasons, those are the reasons. Next let us see that now how we will use and what is the arrangement. You can see that for a column a minimum of 2 piles. That means, if there is a column here, this is the column, and then actually then you have to make a pile cap something like this, and there may be a footing, there may be pile here, there may be pile here. This is minimum requirement 2, but most of the time it will 3 or more will be used. That means, sometime it will be like this and it will be like this, and then there will be a pile cap, and from there actually you will have column. So, or even it can be more, that is 4 column 4 piles, it give a pile cap and then column will be from here. So, that is what for column a minimum of 2 piles, but more commonly 3 or more piles are clustered in a group and connected via a concrete cap to form a unit. So, that means this is actually this external whatever I am drawing, these are actually pile cap. So, all pile cap and pile head all will be connected, so that the all 3 piles will have a common support. So, that if I apply load, it will be transferred to the pile equally as far as possible. And this is a for square pile for a column, and for wall generally a line of single piles. So, suppose this is the wall to be constructed. So, there may be you may have pile cap will be something like this, and your piles will be like this, and this pile, and then this your pile cap, and then from here actually wall will be constructed from here. So, sometime if the wall is carrying less load, single line, if it is carrying higher load, then you have 2 rows, 3 rows, like that it can be. So, these are the, so this is for a simple one, and more commonly there are several other ways of clustering the piles in a group. I will show you one by one. You can see here as I have shown the example, when 3 piles are used, this is the best way to cluster it. How? Because 2 will be there and third one will be in the perpendicular to this, and some spacing may be maintained. The spacing here is, so all this to this, whatever distance, this to this, so equilateral triangle will form all 3 piles. If it is 4 are used, then your 4 piles are used, then your best way to cluster it, actually 4 corner 4 will be there and then will be common pile cap. If 5 piles are used, this may be the best way of configure it. If there are 6 piles are used, this is the best way to do, that means 2 2 2 like 3 rows. Similarly, if 7 piles are used, you can see that is like a hexagon and 6 corner you put 6 and middle you put the 7th one, that is the best way of configuring 7 piles in a group, and there may be column will be constructed somewhere here which carry heavy load. Or suppose if there are 8 piles are used, suppose then that will, this may be the best way, depending on the requirement actually we can cluster, but this is actually the best way to cluster it. Similarly, if there are 9 piles, so this will be the best way of configuring, and if it is suppose 10 piles, suppose this may be the best way of configuring, and here actually you can see the distance between the pile which is called spacing, everywhere it will be same to maintain, and even more than that 10 11 piles. So, this may be the typical way of clustering, and single row when there is a wall, this is a single row of piles and then pile cap, and then there may be wall will be constructed over that. When it is double row, then this is the way actually see staggered actually. So, 2 pile between 2, if you draw a line perpendicular, that will be third one, that will be actually the best way of configuring 2 ways of piles, and if it is 3 ways, then you can see that these 2 will be in line and then in between there will be middle, there will be another pile. So, that way 3 rows. So, this is another 1 row, this is second row and this is third row, and you can see how it is that this and this will be in the same line, but this will be in the middle. So, that is the different ways of clustering the piles. Ultimately, over that actually pile cap will be constructed, and then over the pile cap the column will be constructed, and then the load will be finally transferred to this pile as far as possible equally. If of course, carry the moment and other things, it will not be how to calculate the load in each pile when the load transferred through the pile cap particular that means concentrically, and when it is eccentrically how to find out, that I may discuss later on. But for the time being, if the rigid pile cap is there and if you apply the load through the center, it is expected that all pile will take equal share. So, that is the assumption we do. Next one actually is the efficiency of a pile group. Suppose efficiency, as I have told that actually if I say when I am using suppose 9 piles in a group, and then finally, I have estimated the capacity of the pile the group, suppose I say this is capacity of the group is the q g, and individual capacity suppose q I and multiplied by n. So, this is also n times the individual capacity, that is actually maximum possible, but based on some analysis I may find out the capacity of this, and this will be generally less. So, this divided by this, that will be actually efficiency. When actually we get exactly n times the individual pile capacity, then 100% efficiency. That is also possible in some pile, because of some soil type and spacing, if you use in such a way that you will get 100% efficiency. Sometimes you may get more than 100% also some situation, but most of the time or in a particular situation that group capacity will be less than the summation of the individual capacity in a group. So, in that case that is denoted as efficiency, and as you know the efficiency cannot be generally 100 more than 100%. So, this value should be less than 1, maximum can be 1 only. So, where q is the group capacity and q is the individual capacity. So, that and n is the number of piles in a group. So, here actually it is a group. So, here n is actually 9. next I can see that as I have told that that capacity or efficiency may vary depending on spacing, then type of soil, and then function of the pile, how it is transferring the load, all mechanisms. So, when pile is end bearing, end bearing pile means what? This pile is here and here and load is applied here, and there may be only bearing from here. This is a loose soil, loose or soft soil, suppose here. So, in that case there is no resistance, only there is a steep layer or rock layer. So, pile is directly resting on the steep layer or rock. In that case the load will be transferred to the base, that will be end bearing, that is called. When the pile is end bearing, efficiency will be 100%, because there is no interaction actually, it will not there is no pressure valve affecting each other. So, directly if I load, this is like column actually. So, 100% taken by the pile itself. So, it will be efficiency will be 1 will be taken, and friction pile driven in cohesionless soil, that means if there is a friction pile and particularly suppose sand, cohesionless means sandy soil, if you drive the pile, then your efficiency will be sometime will be can be taken 1, and in some situation actually it can be efficiency can be more than 1. What is the reason actually? When you drive the pile in sand, sometime pile will be densified, and because of this densification effect, that your actual individual theoretically whatever you are calculated based on the soil property, that in the actual field condition your soil properties is increased or improved, and because of that you will have more capacity. So, that sometime though it is more, but we do not take that extra or more value, we take actually 100% efficiency, but individual capacity whatever value we are getting, just multiply by n, that whatever it comes, that will be itself your group capacity, you will not calculate separately. So, though there is a possibility of increase because of the driving in the sand and because of the densification effect, but most of the time we ignore that. Okay. And when for a pile group composed of friction pile driven in cohesive soil, as I have mentioned that. So, number of friction pile, suppose number of friction pile and driven in clay soil, actually then they are all when it create clay soil, and we will not get much of base resistance, mostly it will be from the friction, that means piles will be like this only, friction will be there, friction will be there. So, when there is friction pile, and depending upon now the spacing, if they are very close, then you will have more interaction between the pile. If the spacing is very large, wide, then interaction will be reduced. So, depending on that, the pile efficiency will be, group efficiency will be reduced, or it will be reduced. So, so that means when pile driven in cohesive soil, then and it is a friction pile, in that case your efficiency will be always less than 1, and that has to be estimated. And suppose I get Q I as the individual pile capacity, and suppose in n number of piles are there, and efficiency suppose I estimated suppose 0.8, then your group capacity will be actually 0.8 is the efficiency multiplied by n multiplied by your Q I, something like that you have to find out. So, that how to find out efficiency, now we have to see. You can see that there are number of methods are available in the book literature actually to calculate the efficiency of the pile group, and this is perhaps one of the most used in the practice for calculation of efficiency. And you can see here things are written like this: N g, that the efficiency of the group is 1, that maximum can be 1 minus this value. So, this value will be sometime 10%, 20%, 0.2, 0.3 etcetera. So, 1 minus 0.2 means efficiency becomes 80%, this is 0.1 means 1 minus 0.1 0.9, that efficiency is 90%. So, like that, and this formula is given with a number of parameters you can see here m, n and theta, and this is actually now actually in the group, and one can say m is the number of rows and n is the number of piles in a row. So, suppose if I consider a pile group something like this, So, here both m equal to 3, n equal to 3. So, number of rows 1, 2, 3. So, 3 and each row you can see. So, one row, second row, third row, and this row how many piles 1, 2, 3. So, m also 3, n equals to also 3. And so, this m n is known, then theta, the theta is another unknown. Theta is given tan inverse d by s. So, d, what is d? D is the diameter of the pile, and what is s? S is the spacing of the pile, and spacing, suppose spacing is what? That means center to center distance between the pile is the spacing. Okay. So, this is spacing, Okay. So, your theta tan inverse d by s, d is the diameter, this is d and this is s. So, many a times when you are using calculator, you have to remember that you have to set the calculator in degree mode. That means, tan inverse d by s if you get in radian, and if you use this expression, then you will not get the correct efficiency value. What you have to get? Tan inverse d by s you have to get in degrees. So, you have to set the calculator in degree mode. Suppose you can see here, yes, diameter suppose 0.3 and your s spacing 3 times of d equal to 0.3 and s equal to 3 times d. So, your theta become tan inverse d is 0.3 divided by s equal to 0.3 d. So, this become tan inverse 0.3 by 3, sorry, this is not 0.3 by 3. Okay. So, that has to be obtained in degrees. So, that if I do that, you can see here 0.3 divided by 3 and inverse 10 0.3 by 3 oh no, sorry. Okay. So, you have to either use tan inverse equal to d by 3 d, is it not? This is diameter and this is spacing. So, it will be ultimately tan inverse 1 by 3. Okay. So, you can see tan inverse 1 by 3, that means theta will come 18.43 in degrees, and if you calculate in degrees radian, it will come some decimal values, and if you multiply with this, then it will get wrong results. Now, after getting this, if I put all those things in this equation, what are the things you can see n equal to 3. So, 3 minus 1 it will be 2 and multiplied by 3, again it is 3 minus 1, it is 2 multiplied by 3. So, 3 into 3 6 plus 6. So, it will be ultimately efficiency of group will be 1 minus theta is 18.43 multiplied by 12 divided by 90 multiplied by 3 multiplied by 3. So, if I find out this, then you can see the results how much it is coming, multiplied 18.43 multiplied by 12 divided by 90 divided by 3 divided by 3, it comes 0.273, and if you subtract from 1 minus answer. So, that it gives you 0.7372. So, that means a pile, if you use in a 9 piles like this of 300 millimeter diameter, suppose used in a group 300 millimeter diameter piles, in 9 number of piles used in a group in a spacing equal to 3 times of diameter, then your efficiency coming out to be 0.72, that means 70, that means 30%, nearly 30% is reduced. Okay. So, that means if I get now q I is suppose 100, q I suppose 100 and it is 9 number of piles. So, q group will be equal to 9 multiplied by 100 multiplied by 0.72. So, that become not 9 multiplied by 100, 900 it could have been, but because of this efficiency reduction when you are using a group, that becomes 900 multiplied by 0.772. So, 900 multiplied by 0.72, that means it comes 648 only. It could have, instead of 900 it reduced to 648. So, this because of that one has to be very careful that depending on soil type you have to see that, and type of load transfer mechanism, you have to calculate the efficiency and finally, you have to find out the capacity of the group. And when you are using a group and some very closely, sometime this is actually what actually individual pile capacity you have taken. That means, we are assuming when certain amount of load is applied, all piles are individually failing. So, this is actually based on your individual pile failure capacity consideration. So, that means full capacity is there. If I apply to a load, when pile will fail, that is taken as the ultimate, and then applying factor of safety you have taken allowable, and based on that applying efficiency you have got. Now, there will be a situation when the pile is spaced very closely, then the individual pile failure may not occur. Instead of that, there will be a block failure will be there. When there will be block failure, what will be the capacity, that I will show you later on. For the time being, let it be here efficiency calculation. I will discuss that part in separately later on. The block capacity, that is called block capacity. And now, as I have mentioned that there are number of methods are there for calculation of efficiency, and what method I have discussed, that is actually when you are in a square group, that means square or rectangle, square and rectangle group, that means what it is. So, that means when the piles are like this, here also it is applicable, here also it will be applicable, but when it is irregular like then this method actually will not be able to, because number of rows and column and I am not able to find out from this. So, this will be not be able to apply that. So, because of that there are now other ways to find out. For friction piles driven in cohesive soil, Cole and Suleiman suggested that pile group efficiency may be assumed vary linearly from a value of 0.7 at a pile spacing of 3 times. That means, when pile spacing your spacing equal to 3d 3 times the diameter, there actually your efficiency actually is taken as 0.7, and when the pile spacing is and value of 1 at pile spacing of 8 times, that means A is equal to 8d, then you can efficiency can be taken as 1. That means, when the spacing become 8 times, there is no interaction, no reduction. So, that means from 3d to 8d the efficiency varying from 7 to 1. So, in between if you use 4d, 5d, then we can interpolate the value accordingly between these. That is another method of calculation, and that also work quite fine. Okay. So, this is a different there are maybe many other methods you can, if you use you can read it, but otherwise I will restrict these 2 methods only for your exam and other things. With this I will stop here. Thank you.